We are looking at different versions and flavors of SQL that are available in the market right now. Now, different companies, private companies, and also open source communities are using SQL, which is a language. The most common SQL distribution comes from Microsoft, where Microsoft has used SQL, built up their own SQL server and management studios and the GUI tools and everything to work with SQL. Then we have Oracle, which is again a private company. It's called Oracle SQL PL. Then we have MySQL, which is open source, but it's taken care by Oracle, but it's free. Most of the web community and the one that we are going to use would be MySQL because it's open source and it's free. Then we have PostgreSQL, which is again open source, which is giving competition or which is equivalent to Microsoft's SQL version. And then we have the DB2, which is by IBM. So these are the different distributions. Only MySQL and Postgres is open source and free to use. SQL Server is being managed by Microsoft. Oracle has its own SQL, and DB2 is by IBM, which works with COBOL. Now, you would be thinking why there are so many distributions and what's the idea. The idea behind this different distribution is that every SQL distribution that we want to buy gets integrated with our ecosystem seamlessly. So if we are living in the Windows world, if all the operating system at our company is Windows, we are using C Sharp, we are using Visual Basic, VBA, we are using Excel, then SQL Server gets integrated very easily and quickly and seamlessly, like you could use the same username as your Windows admin and so on, and the security and everything. So the integration becomes very easy, and Microsoft has put in a lot of research and tools to develop that. On the other hand, when we talk about Oracle SQL is used when we are doing more of analytics or Salesforce. Now, Oracle had a strategy that they acquired a lot of small analytical companies. So, like supply chain, they acquired a lot of companies that do supply chain. So, if we are in the supply chain world and we are using SQL to manage that data, then we would use Oracle. MySQL is mostly for web development. All the websites that we are using, like the WordPress website that I have for my company, it's a very simple website, so they're using MySQL. A lot of open source companies are open source community is pushing on for PostgreSQL, which is giving competition or which is a counterpart of SQL Server. And the very old system like the IRS or the healthcare medical system, they use the DB2, which is IBM, and they use COBOL and all those kind of IBM proprietary tools to do that. So those are the distributions. When we look at the implementation right now that are available, we have AWS, Google Cloud, and Azure. Azure belongs to Microsoft. AWS is Amazon. I have an account on AWS. I think 70 to 80% of the market capitalization or like most of the revenues in the cloud, 70% of it is going to AWS. So I use AWS to run MySQL. So my implementation platform is AWS and the distribution is MySQL that I would use. But for this course, we are going to use MySQL on some sandbox websites to run our code. So this was about the versions and the flavor. You should be pretty comfortable if somebody asks you which SQL have you used. If you say MySQL and they would say that, but we use SQL Server Management, so you should be able to tell that the language remains the same. It's the Microsoft tools. And you can also download Microsoft Developer Edition SQL Server and check with that. So you should be able to talk about these stuff, the distribution and the implementation. Because when you look at the job openings right now or different companies, they would say that we are using this on this whatever implementation platforms. They would say that we are using MySQL Server and we are using AWS. Or if it's a bank, banks are generally using Microsoft SQL Server and they're putting it on the Azure cloud, all the Microsoft proprietary tools. So based on where you're going, you have to do that. Since we want to learn basic SQL in this course, we are focusing on MySQL and we are not using an implementation platform. We are going to use a sandbox website. Let's look at the roles and the jobs available in the SQL world. Now, I'm trying to simplify a lot of stuff just to make it easier for you to understand the kind of roles that you can get. Now, one of the roles that is very common is business intelligence or data analytics, information system, which is to make cubes, create a warehouse, create the graphics on Tableau. This is like the most hot role right now because all of the companies have different databases and different department are using different SQL. The finance is using Oracle, the inventory management guys are using Microsoft, and so on. And then you have to make sure that you have all the tools ready. You can create a warehouse of your data, and then you can create reports or cubes or use that data for any kind of an analysis. That's data analytics role. The other is database developer, which is like creating database, deciding the tables, how these tables are linked up, the security and all those kind of stuff. It's mostly designing and setting up databases. So you go there and you set up a database that they interact on a daily basis, which is a little different from the intelligence guys. Then we have a dedicated role of data warehousing and data mining. These guys don't work on the business intelligence part, but they work more on the extract, transform, load, also called the ETL. They load data from different sources, CSV files, different databases, even in Hadoop and big data world, and they get everything ready to create the warehouse. Then we have an exclusive role coming up in the future that's going to be a lot in demand. It's very high in demand right now, which is the security. So we have database security expert who manages all kind of security related issues. And at the end, we have the database admin guys, which takes care of your day-to-day data for your company, which is like the transaction processing. So if you have a company and people are buying something from you, instantaneously you want to update your data, which is like the sales data or something, which is linked to your website and which is linked to your accounting system. So the database that is used on a day-to-day basis, which gets updated instantaneously, which is the live data, that's the OLTP data, and that's the database admin guy. So these are the different roles. In this course, we are focusing a little bit more on the first part, which is data analytics and business intelligence, although we are not going very deep. But we are trying to understand how we can use SQL to move some analytics out of Excel and draw a parallel. So that's going to be our focus in this course. Okay, in this section, which is section 2, lecture 4, we are going to look at how to run MySQL on ephemeral websites, which is like a sandbox or an online place where we can run our SQL code. So I'm talking about 3 websites in this lecture, which is dbfiddle, SQL Fiddle, and Rex Tester. There are others available. You can just Google and find out. These websites are generally called Fiddle, F-I-D-D-L-E. Now we are going to use in this course dbfiddle to run all of our code, and we would be using MySQL distribution because that is the one that is used on the web development world or on the web. Now I'm going to show you all the 3 websites and talk a little bit about how they look like. This is dbfiddle. This is my favorite. In the SEMA SQL, where I'm hovering my mouse, we are going to put the code to create table, and it says create table, insert and update. On the right side, I have query SQL, which is to query my tables. Now, most of the times when we are going to work in analytics, we won't have the right to change the table. We'll just have the right to query the table. So we will have that more often. The other website is SQL Fiddle, which is not working right now. And the third one is Rex Tester. In Rex Tester, I can select any language that I want. So it works for a lot of different languages. But what I'm interested right now is MySQL. If I go back to dbfiddle, and click on database, it allows me to switch between different database, which means that I can run PostgreSQL, SQLite, and MySQL. Be reminded that it cannot run SQL Server because it's a proprietary Microsoft tool. It cannot run Oracle because again Oracle is a proprietary tool. It cannot run DB2. It's a proprietary tool by IBM. Whereas SQLite, PostgreSQL, and MySQL are 3 open source distribution. MySQL is mostly used for the web development. PostgreSQL is used for all of your transactions, like if you are a company and you want to store your business information. It's more of a competitor of Microsoft SQL to give you a more holistic approach. If you are a finance company and you want to store tick by tick data or the data for analytics, then you're going to use PostgreSQL. It's more robust to handle with a nice front end and everything. And then you have SQLite, which is a compact SQL, which you're going to use when you're using Python or some other language where you want to create something on the fly. It's a very light based SQL. If I were to compare it, if you are installing Microsoft SQL Server and the front end tool or Oracle, it's going to cost like, I don't know, 4, 5, 6 GB. Whereas SQLite could be installed in only like half MB or 300 KB. So SQLite is a very light version, a very lightweight, and a very compact version of SQL. So these are the 3 that's available here. In compile MySQL online is going to do the same stuff, but my favorite is dbfiddle, which we are going to use all of the time. Now many of the times one or the other website is down. So while I'm making this video, SQL Fiddle is down. So then you're not going to use SQL Fiddle and you can use dbfiddle. Sometimes dbfiddle is down. So whichever is on, we are going to use that. So coming back to my slide, some of them support SQL Server, some of them does not support SQL Server. This supports a lot of different languages. This supports Postgres. This supports SQL Server. So now once I have SQL Server, I can run a lot of Microsoft tool. And you see here it says SQL Server Express Edition. So this is more harder to get because Microsoft does not allow us to use that tool for open source development world. But our case in this in this course, I'm going to focus more on dbfiddle. Now lecture 7 prepares you to run the code of lecture 8 on your own, which would be your hands-on exercise. I'm going to run this code, and in lecture 8 you have to copy and paste and run this code. So before I move ahead, I want to tell you what we have been doing in the last lecture. If you are following the last lecture, then in the last lecture we got all of our code into dbfiddle, which includes create table and the select statement. So you can find this text file in the courseware. It's called createdb.txt, which is creating a table. I'm putting the create, insert, and the update in the schema SQL, and I'm creating the query in the select star from attendees. Now, if the select star from attendees is working, then we are good to go. Let's check if we have the other table. So I'm going here and I'm writing select star from average salary, and I get the other table. Cool. So I have both the table. Let me show you what happens if you run both of these commands together. So if I run both of these commands, I did a Control A and a Control V in Windows. In Mac, it's Command A and Command V. So when I run both of them, I got both the tables, one below the other. So fantastic, this is working. So select star from and the table name selects all the values. Star stands for everything. Star means all. So select everything from attendees. Select everything from average salary. Always use semicolon to end your statement so that MySQL understand that these are 2 separate statements. So select star from attendees work. Let's move ahead to the next command. Now, if we were to create a new column on the fly when we are getting the data. Let me show you what I mean by that. I'm just running select star from attendees, and I have how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 columns. If I want to create one more column, and why would I do that? Let's look at it. Suppose somebody has got a lot of assets and he has got a very small salary, which means that this guy has been very frugal and he's saving a lot of money. That's why he has low salary and high assets. That's a measure that I want to do for my people, because as I told you, in the analytics world, we have to decide which data do we want and how to use that data to do something meaningful for our company. So maybe people who are more frugal are not going to come to my class that often because they want to save a lot of money. Maybe that's one parameter, who knows? Let's keep that thing into our mind. So let's create a frugal parameter. To do that, go to calculation on columns, copy this code and paste it on the right, and let's see what this code means. If you look at the color convention, select is blue, as is blue, from, order by, and DESC. All these are blue, which gives me a hint that all these are SQL commands. All these are reserved keywords. So select star means select everything, comma, and now I'm calculating two columns. I'm saying go to the assets column and divide that by salary. So the first asset is 300,000 divided by salary. That's 10,000 for Spider-Man. Go to the next one. Assets is 700,000 divided by 10,700. That's for Superman. Go to the third one. The assets is 900,000 divided by salary, which is 120,000 or 12,000. And once you do that, order that by the new column that you just created called frugal measure. So as means an alias. You want to give a name to that column. So we gave a name to this newly calculated column, which is assets by salary, as frugal measure. Once we did that, then we did an order by. Order by, as you can guess from English, is to order all the records using a column, and DESC stands for descending. We're going to play with this code, and that's what I want you to do and post any questions. So let's run this, and then you have to break this code, tear it apart. So we have a frugal measure, and since we did a descending, the person who has the highest assets and the lowest salary kind of a ratio is the most frugal. So we found out that Batman is the most frugal with a frugal measure of 75. Frugal measure that we wrote after as is the column name. So let's see. So miserly measure. Let's assume I have this. The column name is going, so I got an error because the name I have to put here, I have to use here to order by. So I have to change it at two places, and it's miserly measure. What's going to happen if I do an ascending order? So it's ASC. Now I get it in ascending order. So Wonder Woman is the least frugal. Maybe she'll come to my course. So I'm trying to make use of this data, creating new columns on the fly and writing ascending or descending to come up to a business solution that's going to help me to contact these people. So if I were to call or send my promotion and I had this data, I'm going to create a new calculated column and pursue people who are less frugal. Maybe they'll come to my course. So that's the first part, which is calculated on columns. Now let's see. Suppose you want to find out all the people from the attendees who come from the city where the average salary is greater than 10,000. So we have like 4 boroughs. We have Manhattan, Queens, Bronx, Brooklyn, and we want to first find out of which boroughs we have average salary greater than 10,000. Once we find that out, we want to search only people who are in these cities. So here is how it works. Suppose Manhattan and Brooklyn are high salaried places. Manhattan has got a high salary. Brooklyn has got a high salary. Queens has low and Bronx has low. So we want to only find people who came from Brooklyn and Manhattan. So first we want to find the cities, and then we want to find the people from that city. So that is called a subquery. It's also called a query inside a query. Uh, let's paste this code and let's see if we can understand this code. And we are going to tear it apart. All of this course is about tearing the codes apart. Now I'm going to click on run. Everything works and I got the people. If you observe, these are from we never saw what is the average salary. So let's try tearing this code apart. So select city. So I broke it apart very carefully and I just got the thing that was inside the next query. This is subquery is like query inside a query. It's like the movie Inception where you have a dream inside a dream, or it's like a virtual computer where you have a computer inside a computer. There are theories that suggest that we are living in a computer simulation which another simulation ran. So we are a simulation inside a simulation of somebody's simulation. So this is query inside a query, a very famous concept, also called nested query in the computer programming world. So I'm saying that select city from average salary where average salary is greater than 10,000. And it says that there is no column city. So let's find out. So I'm trying to tear this code apart. Select star from average salary. So you have city 2 and you have 4 places. If you see here, Manhattan and Brooklyn have high salary. So I'm going to write select city 2 from average salary. So it's selecting all the cities. Now I'm going to write where average salary is greater than 10,000. I'm expecting only Brooklyn and Manhattan. So I got only Brooklyn and Manhattan. I'm going to put this inside parentheses because I want to use this list. Only Manhattan and Brooklyn. And I'm going to say select star from attendees where. I would like to remind you one thing. Many times we are not working with native English speakers. So they do a lot of spelling mistakes while creating these table names. So always do a copy paste. So rather than writing attendees, I would rather do a copy paste here. So select star from attendees where, and we want to write city in. And this is going to give us 2 cities. So in command is called an array command. So now I'm getting people only from Manhattan and Brooklyn. So that's my code. Now this is my code and we are in the chapter of filtering and selection. And you have to run this code. So I'm going to give you this code, which I'm going to put here for you. So you have to run this code and make sure everything is working. Okay, what if we want to only select the odd number of people? So I want to introduce you to this concept where I'm going to remove select star from attendees. That's going to give me everything. And I want to remove people who are odd or even. I want to only get the even person ID or the odd person ID. So to do that, I am writing select star from attendees where mod is always going to give me the remainder. It's called modulus or remainder function, where mod person ID comma 2 is equal to 0, which means that where the remainder by 2 is equal to 0. So it's only going to give me the even number. If I say this is equal to 1, it's going to give me only the odd number. So this is how I'm going to use the even and the odd. Whenever you hear the term even or odd, you have to think of the remainder function. Let's move to the next place. Now we have to find out the person which is having the highest salary out of my attendees. That's also very useful because I can pitch him to buy my course. He has got a lot of money. So these are the heroes that attended my class, and I want to find out the person who has the highest salary. So first I'm going to write select max of salary from attendees. But this is going to give me the max salary. I want to find out the person who has this salary. So I'm going to write select star from, and this is the dream inside the dream, the world inside the world, the simulation hypothesis, where attendees were salary equal to, or I would also write in. So whenever you use a subquery, you have to write in, or if you write equal to, you have to put in brackets. So X-man has the highest salary. You see, we started with this command, select max salary. This gave us only the salary, which was 12,500. Then we went here, and then we said select star from attendees where salary equal to this 12,500. So these are called nested query. These are very important interview question. How do you find out the person who has the highest salary? How do you find out the second highest salary? Not the person, but the second highest salary. So that is another interview question. How do you find out the person with the second highest salary? So there is a trick behind that. We are going to find out the max salary, and we are going to exclude X-man because he has the highest salary. So select max salary from attendees where salary not in. So this is the trick to find out the second highest salary. So another interview question, and I'm going to put this question in my final interview questions. Okay, so that's the person with the max salary and the second highest salary, not the person who has it, but just the second highest salary. Then we have casting. Casting is like molding an iron into something. So whenever you want to concatenate two numbers, when you want to put two columns beside each other, and these are mostly for optics. So when you have this table and you want to concatenate and write everybody's name and age, you want to create a new column. So if I say select hero name comma age, it's going to display me two columns, but I don't want the two columns. I want them to be in one column. I want them to be stacked across each other, like Spider-Man space 32. How would I do that? So to do that, first we have to create everything into a character. Once we have the character, then we can do that. So suppose I want to find out the salary and I want to use the notation K, like 100K or 200K, because it's painful for me to read the assets like this. I don't want to count the number of zeros. So how would I do that? I'm going to first cast or force the assets into a number, and then I'm going to concatenate it with K. So this is my 300.00K. So that's called casting and concatenation. We are going a little faster here. We never talked about these two terms, but just I want you to quickly dive into casting and concatenation. And then the last statement that we want to quickly know here is called case statement. A case statement is a statement where it's like if else. So whenever we find city equal to Q, then we want to write Queens, else we have to write other city. So an else, if else statement in a Python is called the case statement in SQL. So we want to select a hero, and if he's from Queens, we write Queens. Otherwise, we write other city. So Spider-Man, other city. Superman, other city. Batman, Queens. X-Men, other city. Wonder Man, other city. So that's called case statement. Case when city equal to Q, then Queens, else other city. So it's used a lot whenever you want to do an element by element stuff using an if else. So these are the very common filtering and selection that we are going to do with our data, massaging our data. Right now we are only playing with one table, and we'll see how to join different tables, and we have to see how to use aggregate function, which is coming in the next class. Okay. In this lecture, we are going to look at group by. Group by are also called the aggregation or grouping of stuff. Whenever you do an aggregation or group by, two questions you have to ask. Group by what? What? W-H-A-T. What do you want to group by? Once you know that, then you can move ahead. Let's look at our data and find out what are the questions that we might ask. So I have a data of people who attended my session, and what do I want to group by? Maybe, let's think about it. Maybe I want to group by and find out that people who attended my class from Brooklyn, what was the average salary of those guys, of people who attended my class from based on cities. I'm making a guess that people who attended my session from Manhattan had a higher salary, and followed by Brooklyn, followed by Bronx, followed by Queens. But who knows? Or maybe I can group them by sector. Maybe tech people are earning more, or maybe finance people are earning more. So I want to group by sector and find out the average salary. Maybe I want to find out the average age. Now I already have some idea in my mind. For example, I have an idea that people attending my session from Manhattan have higher salary, Queens have low, and I know a kind of a order. I have an idea that people who work in tech these days are having higher salary than finance. So if I find out the average salary of people grouped by sector, I'll find out that all the averages of people of tech sector is less. I also have a little idea about age. I know that tech people are young. So people who attended my session, if I group and find out their age by sector, I'll see that the tech sector average age was less and the finance sector average age is higher. So on and so forth. I have my business questions in my mind. I have some idea. I want to make sure that are these things matching with my data? If it's not, then I have other questions to answer. So let's go ahead and run the first query, which is select sector, average age, and let's understand the syntax of this group by. So a group by always has two things. First is your aggregation, and the next is by what you are grouping by. What is the question? What do you want me to group by? So I'm saying that select me, give me the sectors and calculate the average salary. That's the aggregation function that I want you to perform from attendees and group by sector. And before I see the result, my intuition would say that people who work in IT right now have higher salary or things like that. Let's go ahead and run this. And we get, oops, let's see what's the error. So I know what the error is. We have to always follow the exact name of the table. So fin guys have 150 and tech guys have 67. That's the average age, not the average salary. So fin guys are older, tech guys are younger. My data is fictitious, but that's what I wanted to show you. Okay, let's go ahead and look at the next group by. I can also use a max asset, so I can find out the max assets from each sector. So this time I'm not finding out an average, but I'm finding out the max assets by each sector. So I want to find out like who earned more money based on the asset. What is the maximum? So I assume that tech people are not able to make money. So I think that the max in IT would be higher max in finance should be higher than the max in tech. So in all the financial world, if I go and find out the maximum assets, it's 900,000, but in tech it's only 700,000. Here my aggregation function is max, it's not average. If I change this to average, it's going to give me the average assets of all the sectors. So the first is the aggregation function. What do you want to do? Do you want to do average? Do you want to do min? Do you want to do max? And the next question is, what do you want to group by? Let's see what's going to be the kind of error if I don't use an aggregation function, because our way of learning is tearing it apart. And it says that you're getting something, group by clause contains non-aggregated column. You did not give me what columns to aggregate, which means that the aggregation column is missing. Let's remove the group by and see what's the error. So then the error would be query with group by, select list contain non-aggregated column, incompatible. And the idea is that you gave me an aggregation, but you never gave me what to group by. And SQL cannot understand. So we have to be careful of what we want. Let's try to revise this and see the syntax. So the syntax is select column name from table, where, group by, having, order by. And one of the very high frequency interview question is the difference between where and having. And let's try to make sense of that. Right now we just did a group by. Before grouping by, we can filter our results, which means that before grouping by, we can filter out the results. We don't want to take poor people, or we don't want to take people who got a discount or who came to my class for free or something like that. Then do a group by, and then use a having, which is another filtering measure to filter on the calculated column, which is the average, min, max, and then order by ascending or descending. Let's try to slowly go inside this. Let's look at this. Let's first understand what is order by. So if I say that select sector and average, so if I say that select sector and average from attendees, group by sector, order by average assets, then it first does the aggregation and then do the tag. Let's assume after grouping by, and I had many sectors, I wanted to ignore some of the sectors where after the group by, the average salary does not cause a threshold. So I would say that where, I cannot use a where on an aggregated column because average assets is an aggregated column. So I'm going to say having average assets greater than, and in this case, if I put 400,000, tag is going to vanish. So that's what happened. So let's paste this code there as an example. So whenever I'm using group by and I'm using an aggregated column, I have to make sure that I use a having, which is like where, but having works only on calculated column. So you have to remember that having is going to work only on calculated column. Now you have to tear this code apart and understand. If I don't use this having, I'm not filtering post group by, after group by, I'm going to get both the values. There are two more examples of having that we are going to see. Let's assume that we want to only talk about my attendees who are greater than 35. We want to find out their average salary. And we only want to see the sectors where the average salary is higher. So we have a having, which is always working with a calculated column. This is pre-group by. So even before I group by, I don't want to take people who are less than 35. So that's pre-filtering or pre-group by, and having is post-group by. So the final and the longest, or the thing that I want to touch is that you have select from where, group by, having, and order by. and having always work with a calculated column. Otherwise, uh, it gives you an error if you try to put a where. Let's go ahead and see the error. So if by mistake I put a where here, which also works as the same one, it's going to give me an error. It's not able to find out the exact error, but it's going to give me an error that the problem is with where, the next where, and then I'll remember that, oh, I should have used having, because this is a calculated column. This is already aggregation that's performed. Where is used before the group by. So that's the group by and having. The high frequency question in the interview is the difference between having and where. Why do you use having? So having is used when you want to do calculated column after grouping by. So that's where you're going to use having. Okay, we are on section 3, lecture 12. This lecture is about joins and union. So we did a group by in the last lecture. Group by is really the same thing as pivot tables in Excel. Pivot tables don't get refreshed in the older Excel. It's kind of messy, but you can do a lot of things that you do in pivot table by group by. Not everything, but a lot of stuff. Now we are looking at joins and union. So when I hear about joins, I want to link it to VLOOKUP and HLOOKUPs, because you want to join and capture data from two tables. You want to join it to your master table or your source table. So let's see what we have. To understand that, we have to understand how many tables do we have here. So I am just scrolling down. I have create table attendees. I have create table average salary and average salary. Let me talk about why we are doing this. So I have people attending my class, and I want to pitch my course. I want to invest. I want to call the right people. I got the data from the census website about the average salary of cities or boroughs here. So I got the average salary of Manhattan, Brooklyn, Queens, and what I'm doing is that when I want to compare whether somebody is rich enough or has disposable income to attend my course, I compare their salary with the average salary of the respective borough. Just imagine if somebody has a high salary but he's living in Manhattan, which means that he does not have any disposable salary to come and spend for my course. Somebody is living in Queens, he has a low salary, but the average salary of Queens is low, and his low is higher than the average salary of Queens, which means he has disposable amount. So that's the whole criteria. So I want to join and put the average salary table just across my main table of attendees, which I'm going to do by copy pasting my code and searching for the common column. So I'm saying select star from attendees, full outer join, average salary on, and I want to join on attendees.city and average salary.city. So let me correct this small error, which means this should be together. And let's try to see what it gives. It gives me an error. So select star from attendees. I'm going to remove full outer join because full outer join is not supported by MySQL. Full outer join is only supported by SQL Server. So I got a new column called average salary for each respective boroughs. That's why I keep on repeating. For Brooklyn, it's 11,000. Here, Brooklyn is 11,000. Manhattan is 12,000. So I have joined them, and by default, it is inner join. So that code, full outer join, is not supported by MySQL. Full outer join is only supported by Microsoft SQL Server. So I'm going to put here that below works with MySQL, and this is for SQL Server as full outer join not supported in MySQL. So that's part one. Let's understand part two. Uh, if I want to first filter and then join, then I'm going to write a where command. After writing a where command, I will create a table because I want to use that table, and then I want to join. So to do that, I have to use alias, which means that the thing inside this bracket is going to be a table which has attendees where age is greater than 60, and then I'm going to join. So that is filtering and joining. Now, if I want to stack across two tables, one below the other, then I'm going to use union all. Union all stacks one thing below the other. So when I run it, it's going to put one thing below the other. It says average salary 2 does not exist because that is because of the case sensitive aspect and my uh, beautifier. So now it puts everything below. The difference between union and union all, let's see. So I have Manhattan, Brooklyn, Queens, Long Island, Manhattan, Brooklyn, Bronx. So union is giving me Manhattan, Brooklyn, Queens, Long Island, and Brooklyn. And if you see here, Brooklyn here has 11,000, and Brooklyn here comes again as 11,000. Let's change this 11,000 to 10,000 and see if it gets repeated. So union avoids it's putting everything below that. So it's just stacking one thing below the other. If I say union all, and if the salaries are same, it's going to give me a duplicate value. So I'm using union all and I'm running, and you're going to see duplicate values of Brooklyn. So Brooklyn is 11,000, Brooklyn is 11,000, while union is going to ignore that because if it's the same entry, why do I even care? So I had the salary from last year and I got an update, but I want to keep only the new stuff. In that case, I'm going to use union. If I want to display and see the duplicate values, then I'm going to use union all. So that's the difference between union and union all. Union all is going to show you everything as the name suggests. It's all. So it's going to give me even you the repeated stuff, but union is not going to give you the repeated stuff. It's going to give you unique stuff. So that's union and union all. Remember that union is putting things below the other, and it's like adding new records, while joins is like VLOOKUP, which you can do using joins in a much more comprehensive way. You're using pivot table in Excel, which you can cover by group by. It's like automating a lot of stuff and working with a larger amount of data. I want you to practice how to say things in English. If I say calculated average salary, it would be select average salary, calculated average salary for all sectors. So it would be group by sectors. Put across rating, or put across something from another table and bring it here. It's like join. So these are the things that I want you to be comfortable with, where you can think about joins and group by and union. If you have new data and you want to stack it across just below your old data, which means that I'm talking about union. Union is like putting new data below your old data. So these are the terms that I want you to have an idea about. The other thing that I want you to check out is the 10 post queries that you have to study. So the top 10 queries include everything that we have studied, including filtering, including group by, including a lot of things. So these are your top 10 queries for revision. This is the same code that I have been using, and when you scroll down, you're going to see code which starts with filtering, subqueries, joins, and group by, remainder function, which you can check out. This file is being uploaded here in your courseware page, so you can download this.